Hello, my name is Florian and I am your PLC coach. You are watching this video because you want to learn how to program a Siemens Simatic Controller by using the software TIA Portal. In 20 minutes you will know how to do that. Let's go!
First, let's talk about the basics. What is a PLC? A PLC can look like this. What you can see here is a Siemens Simatic S7-1200 controller. This is a very common PLC used in the field of industrial automation. When I was a young electrician, I asked one of my colleagues what PLC actually stands for. He replied, "PLC means please leave connected. So always remember, young boy, not to touch this device." Today, many years later, I know that was just a joke. In fact, PLC stands for Programmable Logic Controller. I am a big fan of simplifying things. The best and easiest definition for a PLC is the following. A PLC is a small computer that controls industrial machines. And an industrial machine could be almost anything. For example, a very simple conveyor belt, right up to complicated parts of a nuclear power plant. The job of a PLC programmer is super interesting and well paid. You can work in many different industries such as automotive, oil and gas, the food industry and transportation. Using a PLC for home automation or creating the most spectacular Christmas lights in your neighborhood is also possible. Now I want to show you how a PLC actually works in an easy way. We will compare a PLC with the human body for a better understanding. Both systems work in a similar way. Almost every human being has senses. You can see things with your eyes, hear things with your ears, and so on. Your senses collect data about the environment and send it to your brain. Your brain processes these data. Depending on your inner programming, the brain decides if it's necessary to move a muscle or not. Let's make a super quick example. If somebody tries to hit you in the face from the front, your eyes will recognize that. This information is sent to your brain and processed there. Depending on how life has programmed you, you will use different kinds of muscles. Maybe you fight back, run away, or call the police. The connection between your senses and your muscles depends on the programming in your brain. But why am I telling you this story? I'm doing this because a PLC works similarly. Of course, a PLC does not have any senses, but a PLC has sensors. You can connect many different sensors to a PLC. For example, a proximity sensor, a photoelectric sensor, a sensor that measures a fill level or a temperature. Even a push button or a switch is kind of a sensor. Sensors are the eyes and ears of a PLC. With these, the PLC collects data from its environment. Like the human brain, the CPU inside the PLC processes the information the sensor collects. The CPU is the place where the program we have written is stored. Depending on our program, the CPU controls actuators. This could be a motor, a valve, or some signal lights. I hope you are now able to see that your body and a PLC work in a similar way. Let's give a practical example to help us understand what we've learned even better. Here you can see a little conveyor belt. We will program this together. A sensor at the start of the conveyor detects the part placed on it. You can also find a sensor at the end of the conveyor. Our simple goal is that the first sensor starts the conveyor and the second one stops it. When one of the sensors detects a part on the conveyor, it sends a 24-volt signal to the PLC. The CPU, the brain of our system, processes those signals. The PLC controls the motor of the conveyor belt depending on the status of our sensors and the program we will write soon. Before we start programming, I want to show you something very important. Please have a look at these small LEDs. The upper ones show the status of the digital sensors. We also call this an input. When the sensor detects a part, the input LED lights up. Each input has an address. If you want to use the status of a sensor in the PLC program, you must know its input address. The address depends on the sensor's wiring and the configuration in the TIA portal. I will explain more about this very soon. Wiring a sensor is not as complicated as you might think. Our sensor is using only 3 wires. You need the brown and blue ones for the power supply. The black wire sends the status of the sensor to the PLC. Our sensor is a digital sensor. That means it can only send 0 volt or 24 volts to the PLC. On the lower side of the PLC, you can also see some LEDs. These LEDs show you the status of the outputs. Our actuators are wired to the outputs. If the output LED lights up, the motor of the conveyor belt is running. Each output has its own unique address, which again depends on the wiring and configuration. Before we start programming, I want to give you a quick overview. The brain of our system is the CPU. Sensors send data to the CPU. If you want to use the sensor in your PLC program, you must know its input address. The address depends on the sensor's wiring and the configuration in the TIA portal. For example, by default, our first sensor has an address of I0.0 and the second sensor has an address of I0.1. Actuators are our system's muscles, like the conveyor belt motor. If you want to control the motor, you must know its output address. Again, the address depends on the wiring of the actuator and the configuration. In our case, the motor has the default address Q0.0. A giant PLC can be connected with hundreds of sensors and actuators. Nobody can remember all of these input and output addresses. For this reason, we have to create a unique name for each address called a PLC tag. The first sensor with address I0.0 will receive the name sensor start. The second sensor with address I0.1 will receive the name sensor stop. The actuator with the address Q0.0 will receive the name motor. This summary is all we need to program our conveyor belt. Now, my friends, the time has come to open the programming software TIA portal. We will create our first PLC project. If you start the software for the very first time, it should look like this. If you have not installed the software yet, there is a link under the video. Siemens offers free trial versions which can be used for a limited number of days. This is perfectly fine if you want to take your first steps as a PLC programmer. First of all, we have to create a new project. Type in the name of your project and select the path where it is saved. After that, click on Create. Congratulations! You have successfully created your first PLC project in the TIA portal. Now let's switch to the project view to continue our mission. The next thing we need to do is add a new PLC to our project. Please click on Add New Device. Here you will find all the controllers your TIA version supports. For our conveyor belt, we use a Simatic S7 1200. The Simatic S7 1500 is a controller for more advanced applications. Siemens is offering many different S7 1200 CPUs. We use a CPU 1212C AC-DC relay. The article number is this one. Now click on OK. The security settings will appear if you use a newer version of the TIA portal. Security is becoming a big thing in industrial automation. For this reason, Siemens helps you to protect your PLC. We are just at the beginning of our journey to becoming PLC programmers. At the moment, security is not important for us. For this reason, we will switch off everything related to security. Now we have successfully added the PLC to our project. If you zoom in, you can see the input and output addresses. You can change these addresses by clicking on Device Data. However, we leave it at the default settings. Every device in a network needs a unique IP address. This address helps us to identify the devices within the network. You can change the IP address in the PLC properties. In our case, default settings are perfectly fine. We are professional PLC programmers. We do not use addresses like this in our program. As I told you, we will create a PLC tag for each address. I will now create a PLC tag for the inputs and outputs. After that, we are finally able to write our first PLC program. To do this, please go to Program Blocks and open the main program OB1. Very small programs like ours can be written into the organization block OB1. You can also add more program blocks, such as functions or function blocks, for a better structure. In our case, this is not necessary. We keep things simple in this video. You can program a Siemens PLC in different programming languages. Ladder logic is the most used language around the world. For this reason, we will use ladder. Ladder logic is the default programming language in the TIA portal, so we don't have to change anything. You can program in ladder very easily. Just pick up the instructions and place them on your network. Almost everything in the TIA portal works with drag and drop. You read this programming language from left to right. So, when sensor start is true, the motor of the conveyor belt should start running. These red question marks can be replaced with the PLC tags we created a minute ago. To show you what will happen now, I have downloaded the program into the PLC. When sensor start detects a part, the motor is running. Of course, this is not our goal. So let's get back and change our program. We aim to keep the motor running until the second sensor detects a part. The TIA portal offers many different instructions for a wide range of applications. We need a so-called set-reset flip-flop. If you need more information about instructions, just click here. The TIA information system is a very important tool for every PLC programmer. Here you can find out what the different instructions are used for. Of course, I can't explain them all in this short video. For example, this instruction is used to set and reset a variable, so exactly what we need. I will now optimize our program a little bit. I think this will work. Now we must download the program into our PLC. Before we can do this, we need to connect our computer and the PLC. Therefore, we use a simple network cable. If you want to download your project into the PLC, click on the CPU and then Download to Device. You now must choose the PGPC interface. We have connected our computer and the PLC with a network cable. The PGPC interface is the network adapter of our computer. The name depends on the manufacturer of your computer. You could therefore have a different name displayed. Now let's search for compatible devices. My PLC is brand new. By default, a PLC has no IP address, only a MAC address. The PLC is assigned the IP address from the device settings during the download. So only brand new PLCs use the MAC address. A PLC with a downloaded project uses an IP address to identify. If you want to know if you are connected to the right PLC, you can let it flash. As an experienced PLC programmer, I know that many problems can appear during the download of the project. For example, there are many different types of connection problems. We will not discuss that in detail in this video. This video should give you a short overview. If you want to know more about PLC programming, please follow my channel or check out my homepage. Now let's finally download the project to our PLC. We have successfully downloaded the project into our PLC. If you want to watch your program live, you have to go online and switch on monitoring. Our PLC is still in stop mode. This means that the program is not executed. If you want your PLC to execute the program, you have to switch to run mode. Our program is being executed and we can watch it live. And this is exactly what we are going to do now. So lean back and enjoy the show. I would say our PLC program works perfectly fine.
Congratulations guys! Over the last 20 minutes you have learned the basics of PLC programming. You now know what a PLC is, how to create a project, write a little program and transfer it to the device. This is enough for one video. But if you're interested in more, please follow my channel and check out my homepage. Thank you very much for watching.